please help me in welcoming our next speaker to TSConf. He's been building web-based software for over 12 years and has spent the last 2 focused specifically on mobile. He's the organizer of Mad.js and Node School in Madison, Wisconsin, and he works at Ionic, where he's been building the StencilJS framework with TypeScript, and that's what he's here to talk about today. So please join me in welcoming Josh Thomas to the stage.
Thank you. Hi, I'm Josh Thomas. You can find me on GitHub or Twitter as jtoms1. And today I'm going to be talking to you about how we built StencilJS with TypeScript. I am a senior developer at Ionic, and I'm also one of the creators of Stencil. Back home, I have 2 daughters in Madison, Wisconsin, and yes, my house usually is as crazy as this photo makes it seem. About 2 years ago is when I joined Ionic, and at the time I was primarily writing React applications, so it was all Babel and ESLint, and I love writing JavaScript. At that point had been doing it for probably 10 years. So 6 months after I started, I was tasked with rewriting our Node CLI in TypeScript. For the first 2 weeks, this is how I felt. I hated TypeScript. It was constantly complaining at me, telling me what I was doing wrong. But after about that 2-week period, I started feeling more comfortable and I started embracing the type system, and I learned that I actually loved TypeScript more than I ever loved JavaScript. I've been writing TypeScript for about 1.5 years now, and you could say I kind of evangelize about it. Anyone I find writing JavaScript, I try to convince them to write TypeScript because it really is just such a great experience. So how many people here know what Ionic is? Cool, all right. Ionic is a cross-platform web UI kit. It allows you to create one code base in HTML, CSS, and JavaScript and deploy it to multiple platforms. You know, that could be mobile platforms with Android and iOS, or it could be on the web somewhere. So the example that I'm showing here is one application that we built deployed to both Android and iOS, and notice how it appears a little bit different depending on the platform, and that's just because we recognize the platform it's going to and modified the CSS a little bit. Ionic has been called the bootstrap for mobile, and sorry, I have to do this, but it's time for a vanity metric. We're the number 3 starred project on GitHub right now for TypeScript. And that's behind VS Code, which is number 1, and Angular, which is number 2. Originally, when we built Ionic, it was on AngularJS, and it was in JavaScript. In our second iteration, it was built with Angular, and it was done with TypeScript. And at the time, we had the option of either supporting JavaScript and TypeScript, like Angular did, or just going with TypeScript only. We decided to go with TypeScript only because it was a simpler implementation for us. We're really glad that we did, because this is pretty much how we feel right now. Everything TypeScript. So all of our Node code for our CLI, our web applications, our websites, the next release of Ionic, Stencil, it's all in TypeScript now. And one of the things that we've really noticed over the last couple years is that the JavaScript ecosystem is changing. All the major frameworks that are left are really good. And it seems like their conceptual models are starting to more closely align with each other. So the question for us isn't what's the best framework? It's really which one do you prefer? And with Ionic, we want our components to work with you, no matter the framework you're going to use, or with no framework at all. And in order to accomplish this, we need to be agnostic in our own code. We want to be able to write one code base and use that everywhere, with every framework or with no framework. And our answer is web components. So this allows us to leverage the web platform to build our own components. And it's the right time, we feel. Chrome has full support. Safari has full support. Firefox is shipping support this week. The only holdout is Edge. But it can be polyfilled. So we found our answer. We started converting all of our components into web components. But we felt like the experience was kind of lacking, working with just vanilla web components. So we wanted to smooth over the edges a bit. So we started creating our own abstractions on top of web components to make the process a little simpler for ourselves. We didn't plan on building a new tool. We just wanted to make Ionic better and make it work everywhere. But after a few months, we realized that what we were building, the abstractions we had created, could be useful to other people. So we took this tool, we moved it outside of Ionic, and moved it into its own repository and called it Stencil. Stencil is a compiler that generates web components. And this diagram shows you how we think about it. Stencil sits at the top. It creates web components. Those web components are used in Ionic, and then Ionic can be used with Angular or Vue or React or on a website somewhere. Two things that are very important to us and probably important to most of you as well is what is the developer experience going to be like when you're working with web components or working with Stencil, and what's the performance going to be? Well, we were happily surprised that it turns out web components are actually, they render a lot faster than what we expected. This is one of the nice things of using HTML for your slides, is that you can just put web components in your slides. So this isn't a video. This is actually about 850 web components on a page right now, constantly animating and updating every second. So the way it updates is at the very top, there's a set interval, and it's passing a number down through props of children all the way down through the tree. So this is a demo we like to show for people who think that web components really can't perform as well as others. So inspiration for the developer experience from Stencil came from quite a few different places. Angular, React, Vue. We tried to take what we liked from other frameworks and use them in our own process. The most important thing for us was starting with TypeScript, obviously because TypeScript all the things. We like reactive data binding, which comes from Vue. We have an asynchronous rendering queue, which means that every time a component gets rendered, it gets placed into a queue, and then we do optimizations based on the prioritization of the queue. This isn't exactly like React Fiber, but it's a very similar idea. We also have a virtual DOM implementation, and your components, at least the templates of your components, are written in JSX. One of the core features of our components is being lazy, just like our developers. When a component first hits the DOM, when the tag is first seen by the browser, we download the corresponding code and we wire it up so that the TypeScript class comes in and becomes responsible. It sounds like it's going to be a lot of requests, but we intelligently group multiple components together, so it's really not too bad. We want to be type safe, so obviously TypeScript, but one of the advantages we have is that when our components are created and packaged, if you're going to use one of our components in another framework usage you have, as long as you're using TypeScript, you're going to get full type support from the components. We want to be as tiny as possible, which means as few polyfills as possible, at least within the components themselves. And we want to be future-proof, which is a tall order, but a component that's built today should work on a framework tomorrow. So this is an example of a very typical Stencil component. And you can see right now that we make heavy use of decorators. And each component really is just a vanilla TypeScript class. So this component doesn't have every decorator we support or every lifecycle hook, but it does give you an idea of what our components look like. And I'll go a little more into depth later in a demo. And yes, I know decorators are still stage 2. And they're experimental, but it doesn't really matter for how we use them. The first thing I want to highlight is our component decorator. Who here writes Angular or has written Angular? Quite a few. Cool. So Angular has a component decorator that does kind of the same thing, assigns metadata about the component. We then have 2 property decorators. One is called prop and one is called state. Prop designates the properties or attributes that can get passed into the component. So anytime one of those props were to change, a re-render occurs. State designates the class properties that combine the state of the component. So if any of those change, we reactively notice the change and then we re-render the component as well. We do have method decorators, in this case watch, and I'll show you how that works later. And then we also have a lot of lifecycle hooks, like component will update. If anyone's used React, you probably know that name quite well. A lot of our lifecycle hooks are named very similar to what React does. And the last thing, which is a little difficult to see, but it's a render method, which just returns JSX. And if you're coming from Angular, you might be allergic to JSX, but you should know that it's really expressive and it's a nice thing to work with, and TypeScript supports it out of the box. So we have a laundry list of requirements, and what we realized is that for all the things we wanted, the language and a runtime really wasn't going to accomplish how we wanted it to work. So we decided to build our own compiler. And we were already using TypeScript, and TypeScript has a compiler API, so we just made use of it. And it turns out it was a great coincidence. So this isn't the first time you've heard this morning, but does everyone know what this expression means? Yeah? You like to eat sausage, but you don't want to see what the factory looks like. But for now, I'm going to show you what the internals of our Stencil compiler look like. So there's a lot of information that's important to us in every component. So the first step we have in our compile process is collection of metadata. And you can see the first thing we do is ts.createProgram, which is kind of the entry point of working with the compiler API. Then we're pulling the type checker from the compiler, and we're pulling the source files that it was going to be running across. Oh, sorry. And then we have gather metadata, which is the function that we use to get information from every component. So this is a simplified version of how our metadata gathering works. So we walk the AST of every single component file, the same way that TypeScript does this. And you'll notice that when we're gathering this information, most of it is coming from decorators. So the parameters that are passed to decorators, as well as what the property that the decorator is on, and the types of the property as well. We also test to see if what's being passed to the decorator is actually valid and what we would expect to see, and we can fail loudly if there's a problem. So all this metadata that we're collecting, we do end up just adding right back into the component in a more normalized process where the data has a standardized format for our runtime. After we've collected all the information from metadata, next thing we're going to do is start transforming the code. And what you'll notice here is that the same thing, ts.createProgram, and we're using program.emit. And you'll see that from our collection of transforms, there's a list in the before and list in the after. So how many people have worked with compiler API of TypeScript? Cool, a few. So this is probably familiar to you. In the before, that happens before TypeScript does its own transforms. The after is after TypeScript has completed its transforms. So the first transform we do is delete all the decorators. We've already gathered the metadata, we don't need it at runtime, and we don't want to deal with the polyfill that gets put into every component. And then we add the component metadata back into the component. And we're doing that by just creating some properties on the class code. The next thing we do is we have a build conditionals transform. So let's say that your collection of components, you've got 10 components, and out of all of them, they're using only a subset of features that are offered by Stencil. Well, using the compiler and realizing the metadata you have in all your components, we can tell what features you're using. So when we have the runtime code that we create from Stencil, we're actually able to reduce the amount of code we ship to the browser based on your own usage patterns within that particular project. The last thing we do after TypeScript has completed its own transforms is to remove a lot of information that's no longer needed. I don't really want to go over this too much. And then we also gather more information about how components relate to each other. And we do that because it allows us to be smart about how we combine components. So if you have component A and component B, and component B includes component A in part of its source, then we know that and we'll use them together and ship it to the browser that way. We also have a concept after the transforms have complete of upgrading them. So this isn't needed for all Stencil components, but let's say that you built a component in 007, which is an older version, and you want to use it in a newer collection, which is 0.1. Well, if we made any breaking changes within that period of time, we're actually able to write code mods against those changes because we know exactly how the API has changed over that time. So it's likely that you don't actually need to go in and change your code. We can just update it for you. The asterisk is there for one good reason. We've been able to do this twice so far in the project because we haven't had that many breaking changes, but I can't see the future. I can tell you that we will try to continue to do this, but I can't say that it's always going to happen. We also do docs generation, which is very similar to what TypeDoc does, but it's a little more specific to our own components. Okay, let's do it live. So now I'm going to do some live coding and show you what components look like and how they work. Okay, first thing I'm going to do is spin up our dev server, which opens a browser. Okay, you can see it runs through here, starts the compile, finishes the initial compile, bundles components, and generates some map files. So you might recognize these. These are actually components that I included within my presentation, and they're actually in this HTML page, just so I have an example for you. And this is what that HTML page looks like. So has anyone worked with web components? Of course. Yeah, a few people. Cool. So this is how you just include our web components that are built with Stencil into a page. You include a script tag at the top, and then you just start making use of them by tag name. It's pretty simple. In this case, GitHub intro and user ID, and passing in my own user ID from GitHub. So this component gathers information from GitHub and then creates a nice stylized intro. And then we have an image mask, which I use throughout the presentation, which allows me to take an image and put a mask over it and create a window. Right. And this is what you have. Pretty simple to use. We wanted that experience to be great, and it really is easy to incorporate. So if you want to see what it looks like in the browser, very similar. In this case, I'm not using Shadow DOM for simplicity, but okay, so we have a attribute here called user ID with my user ID being passed to it, but we can actually just change this on the fly, and the component will realize this and update itself. So let's use one of my colleagues. So this is one of the nice things about working with web components is that you can just modify the attributes within DevTools, and it just immediately updates on the page. And let's take a look at what actually happened there. So when I changed that, I went to GitHub, I fetched some information about the user, I updated the page, a new image came in, and it updated. So let's take a look at what that code looks like. Okay, so here's the component. I'm importing some decorators at the top. I have GitHub data, which is just a simplified version of the GitHub API with types. It's my component decorator. And we see that I have a watch method here that says anytime a user ID changes, I'm going to fetch information on that user, get it in JSON, and then update the localized state. When the state updates, the page re-renders, and we see the updated version. Okay, so this is what it looks like when you're writing it. And then here's some JSX. This is what actually we compiled to. So let's see these side by side. Types are stripped out, of course. Decorators are stripped out. But you'll notice that this really is very similar to what you created. But the decorators are removed. Of course, the JSX is compiled down. And then here at the end is where we're adding that metadata back in. One of the other things that we create during this process is we actually modify global scope for TypeScript. And we insert some information in there specific to the components within your project. So we register some things with JSX, and we also register things as HTML elements. There's an interesting reason why we would do this. So anytime you were to use one of our components in your project, let's say that I'm just going to use GitHub intro here in the JSX. Yeah, I know. There we go. So it complains because you've defined user ID as a number, or I'm sorry, as a string. You can't pass a number to it. So it's kind of nice that you get that type analysis within your JSX. One of the other nice things is that you can actually do this. So document get element by tag name, give it a GitHub intro, and we're actually able to know based on the tag name that you've looked at what type it is, and then we can include the type information. So GitHub intro.user ID, and we know that that's a string. And you get info about it. Okay, next steps. What are the next steps for Stencil? More documentation. This is what every open source project says, right? We need more docs. Well, I think really what we need more is more examples for people to understand how to approach specific problems within Stencil. But that's coming on our road to 1.0. We're currently at 0.7. And we also need to create framework integration tests. If we say our components work with Vue and Preact and React and Angular, we need to have the tests that back that up. Ideally, all of those components, it should just work because they're web components, but what we know is that web components really don't work all the time how you would expect them to in every framework. So we want to make sure that our components work as well as possible, and if there is a problem, we can document how to work around it. So thank you. I have a few links here. This is links to the documentation for Stencil's website. Links to this presentation is on GitHub, so if you want to look at it and see how I accomplished some of the things with the components. I have links to the compiler API. This is how you get started with using the compiler API from TypeScript. And then I have a link here to astexplorer.net. If you have ever worked with an AST, or if you're ever planning to work with transforms with TypeScript, get familiar with this site because it is pretty amazing. Put some code in, and on the right panel it shows you the full AST, and you can walk it as though it were a tree. It's very nice. Okay, that's it. Thank you.